So I've got Phil Beisel on because it is, time to talk to Phil about engineering kinds of things.
Oh boy.
Yeah, yeah. I mean, that's what we get you here for, Phil, is, I joke with you one day about, pipe smoking and stuff, and I don't think you even got it. Is
Sounded academic to me. I'm sorry.
an academic to you? Yeah. So
No.
my dad's era, when he was an engineer, it was this whole thing of the prep of the pipe and the scraping out of the bowl, and then so that it was perfect inside, and then packing the tobacco exactly the right amount of pack, and then lighting it exactly in the right place so that you anyway. So this is
Meticulous, huh?
well, and it was an engineering, feat to do the perfect pipe.
I
So
think the closest I come to that obsession is espresso.
espresso, okay.
Yeah, yeah. I mean, I don't, well, I used to do it on my own and I got tired of trying to chase that. It's like ridiculous. Like you go to a place in Italy and they make the most amazing espresso possible, and then you try to do it yourself and you're like, how many variables are here? Like there's only 10 things, but oh my God.
Yeah,
There.
yeah, yeah. All
So
right. So what we got this week, obviously, is FSD, FSD, FSD. It is,
yeah.
I mean, everybody's talking about it. We've got, business with leaving steering wheels in or taking steering wheels out. And quite frankly, the putting steering wheels back in, which Farhad kind of, I think, started, got way more traction than my taking steering wheels out. But I think my taking steering wheel out is way bigger deal because it's going to happen. So I don't think, we'll talk about that first, is I don't think we're going to be putting any steering wheels in cybercabs, and you can disabuse us or abuse us or whatever you're going to do about that.
Yeah, yeah.
Then I want to talk to you about the timing on taking all the steering wheels out. I think from there we should go into, where are we really with FSD right now? And then how does that apply to Optimus? Because FSD, it's the same chip. So
Yeah.
those are kind of, I think, what I want to do today. So let's start off. Farzad said, "Hey, why don't we put a steering wheel in the Cybercab, and we can, sell a few thousand, a few tens of thousands of little two-seater cars. Everybody really like it. It's really cute." And you say,
What a waste of time. No, I mean, here's a way of framing this, right? Um, Toyota is the largest auto maker in the world, 10 million, roughly 10 million units in 2024.
right.
Tesla comes in at about, let's call it roughly 2 million units. Actually, Toyota is about 6x larger in production than Tesla, right? But from a market cap point of view, it's ironically 6x
The other way.
smaller. And so my comment was, while Tesla leans in to the future and does autonomy, Toyota just does more auto.
Mhm.
And well, my thought was, I wonder how many autos, think of it this way, how many autos would Tesla have to do per year to be much more valuable? And the answer is there's never a good enough number.
No.
Okay, there isn't. Like, so if you did it, if Tesla did 10 million, would they be a $5 trillion company? I really don't know, but I doubt it because really, I think what's driving the value in Tesla is that Tesla's leaning in on the future and Toyota's just stuck, where it is. I mean, and Toyota's progressive compared to our friendly legacy makers in the US. So, you know, the point is that I don't see I can see that yes, you would sell tens of thousands of unit of Cybercab with driver controls. Absolutely, of course you would. Um, but so what?
Yeah.
That's the point I'd make from more of a business perspective. From an engineering perspective, oh my God, I think that it's a misunderstood concept that you can look. I think Cybercab as a vehicle program started with dual purpose. I literally think that the design was let's build a smaller format car that we can come in at a much lower price point, and also let's build an
Mm.
autonomous car to lean in on our future. And I think Elon said, sorry, in that fork in the road, I'm taking this, I'm going down this path.
Right.
And cut that off. And once it was cut off, it feels to me that it's not recoverable, and nor should it be. Like at this point, Cybercab is a robot, and that's what it will be. And I say to people, I said, of course I can be wrong. Of course they can directionally change, or they could add the program back. But they've done a lot on that car from an engineering perspective to make it the most efficient, low cost, efficiency everywhere.
Right.
From, the manufacturing process is new and interesting, and takes the human out of the loop. I mean, it's like the car that takes the human out of the loop from the manufacturing, including the
Right.
aspect of controlling the car itself. But I mean, every little thing. You've got different tires and wheels. You've got there's no rear view mirror. There's no side view mirror. There's no rear window. Um, the inside is done more as a lounge and not as a driver centric kind of. So while I don't think Farzad was being whimsical about you could just slap, driver controls in there. And by the way, we've seen versions of that car with driver controls, but Lars made comment on that and he said, yeah, that's because we have to drive them around to, from an engineering perspective, we added those controls. We don't intend to sell a car that way. Well,
Right.
he didn't actually say the last part, but
Yeah.
the inference is that what he was saying is, look, we had to put driver controls. And by the way, that is a very different version. When you kind of like just put some engineering harness driver controls in there, that is not like they've set them correctly. I suspect that as this program took a fork, think of it as a vehicle program, or first off, you decide on a platform, right? So like a platform gives you a whole kind of setup for what you're going to do with that car. So S and X are a platform, 3 and Y are a platform. Cybercab is kind of its own platform. Semi is a platform, and obviously Cybertruck is its own platform. Yeah, but you don't embark on platform choices whimsically. Those are huge investments. It involves everything from the manufacturing, to all the selections of like what your electronic architecture going to be for that, et cetera, et cetera. So Cybercab has gone down a path, I don't know, many months ago, where it's a robot, and I think the open question, the one that's debated less than the one of putting driver controls on it, is who's it going to be actually sold to? Is Tesla going to keep it as a fleet car, or will it be sold to individuals to allow them to add it to the robotaxi fleet? I don't know the answer to that.
Well, and by the way, it doesn't have. I have this theory that eventually no individuals will be buying Tesla cars at all. So because they'd just be too expensive. They're if you don't use it as a business, somebody will buy it from you to use it as a business.
Well, it's yeah. I mean, a very interesting thing that I was listening to, and I often chat with Jeff Lutz, and
Mhm.
incredible mind for all things about supply chain, and he probably talked more cogently about any of these topics than me by far. But um, what what he what he says, well, I mean, he says a lot about these things in terms of ultimately the investment in these various platform, and where the endpoints are. But what I think he's leaning in on is something kind of saying this is the point where Tesla is likely to start to change the business model.
Mhm. Mhm.
And I don't think he tells us. I don't think Jeff tries to guess that through, but I think we're going to go in a place, say with Optimus, where the product is never sold to the consumer. It's leased, maybe leased by the hour. And we have this thing on the horizon now of, well, is vehicle ownership a thing in the future,
Mhm.
right?
Mhm.
Is, whether you lease it or you buy it, you get a loan or you just buy it outright, those things are still kind of an ownership model.
Right.
Um, and is there a more flex plan to that? Is there a way to imagine sort of a different form of a lease, more like a rental by the hour? And
Right.
then what does that mean?
Yeah.
This is an autonomous platform.
Yeah.
Um, there's also this thing about there are a bunch of us, and it's largely our age group, if you will, that
Thank you for including me in that group.
I feel I'm getting there. Yeah. So no, I feel like there's a if you go from let's say 45 up,
Right.
uh, most people are still thinking of vehicles as control and freedom,
Right.
freedom of the open road uh,
And a
and
little bit of sport.
yeah, and when my former employer Rivian, the whole brand was built on, it's an adventure vehicle. The whole idea is to, it's like, it's almost odd to think of Rivian having an autonomous vehicle because in a sense, the whole point is to drive the damn thing and drive it, in this case, maybe off road.
Mhm. Mhm.
Um, but I don't want to say it's a niche thing because Rivian's not attempting to stay completely in that little niche area, but it is we are changing. We are changing it,
Yeah.
and for most people that are in the prime of their careers, uh, that are moving around in a vehicle, it's heavy commute hours that are of no joy.
Yeah. Right.
You know,
Negative.
so yeah, I mean, so it makes sense that a vehicle that is fully autonomous what one gives certain people freedom back, people that are of the age where driving isn't something they should probably be doing.
Right.
Um, but at the same time, it gives people their time back if they're commuting.
Right.
So Jeff, the point Jeff is trying to make is, are we about to change the business model here?
Mhm.
Is Tesla about to disrupt in a different way, not just in terms of the actual physical
Sure.
vehicles and their capabilities to be autonomous, but is it about to disrupt in how we think about ownership of the very vehicle itself?
Yeah, I think it would be obvious, and maybe let me know in the comments below if you don't agree. I think it would be obvious that let's say 10 years from now, nobody will be buying a private vehicle. They might be buying a few used vehicles for fun, they're still out there. They might be buying a few used vehicles for very, very specific purposes, but I don't think there will be enough business to justify a line of vehicles that are not autonomous. I think there will be whatever factories are left making automobiles, they will all be autonomous. And you can't make 10,000 vehicles a year. You can't even make 25,000 vehicles.
Well, Randy, the weird part about that, I think, is that with few exceptions, and possibly my former employer, I wouldn't really get much into that, but I'd say Tesla is actually peeling off here. They're literally peeling off into a place where honestly, they're only company that will offer autonomy and EV. Like autonomy and EV go hand in hand. There's
Mhm.
nobody that can convince me logically that an ICE vehicle is going to be equipped uh, as a autonomous vehicle. And a lot of people say, what it can. Well, can and
Mhm.
probable are different things, right? Like anything can.
Right.
I'm suppose we could fit a horse with autonomous controls,
Right.
but
They were
why would
actually
you?
quite good at autonomy.
What's that?
They were actually quite good at
Yeah,
autonomy,
exactly.
especially halfway through the ride when you turned them toward the barn. You didn't have to do
That's
anything.
that's right. That's right. That's right. Good. Very good point. Um, yeah, I mean, it's it, it- the thing about ICE cars is that really their entire systems are mechanical and there are very few of them that are drive-by-wire cars.
Yes.
So without major architectural changes, and we're talking about probably at the platform level,
Mhm.
Most of the manufacturers cannot be retrofitted with an autonomous system. That's why you see Waymos or certain specific vehicles, because those vehicles were built so that on the CAN bus, the network inside, you could emit controls from a controller. Imagine you have this autonomous system that's got its sensors retrofitted, bolted, whatever, onto
Hmm.
that car, and then it's got to feed it, and it comes up with a solution. It comes up with a control actuation request of steering angle, braking, accelerator, and it's got to tell the car to do that. Well, most cars can't do that.
Right.
You have to physically steer them. Um, you have to physically press the accelerator pedal, and some cars, but there's not many. You can you can invoke those commands. Where like with a Tesla or frankly a Rivian, entire systems drive by wire.
Right.
And so it's all done through, like when you press the accelerator pedal, that's going through an electronic control unit that's evaluating the pressure or whatever, and then giving a value to a system that then decides what to do at the motor level. So you're not going to see ICE cars magically turn into autonomous vehicles, and those that manufacture ICE cars have no tech stack.
Yeah.
They have no tech stack.
Right.
So what's really interesting is I think we're going to see it peel off to the point where if the future is an autonomous future, the only provider out there right now with what will be a level 5 solution at scale will be Tesla.
Right.
And that's
So,
a weird thing because it I would say that the legacy automakers in this country, with every move they make, is literally like a plan to put themselves out of
right,
business,
right. Yeah.
right?
Well, we've seen this before. We've seen it
Yeah.
with, with Kodak. We've seen it with, with the other phone makers. We've seen this disruption before. But so what I was trying to do a little bit there was say, okay, let's go in extremis and go 10 years out.
Yeah.
In 10 years out, we have the vehicles that are in this case will be 100 times safer than a human or whatever. They will also be
Yeah. Yeah.
communicating with each other.
Yeah. Yeah.
So putting a human-driven car into on a freeway or a surface street, along with cars that are communicating with each other and driving autonomously, would actually be dangerous. So I don't think
Well,
there's.
yeah, I mean, it would, it will certainly be possible, but people will not select that option.
Right.
So, I mean, we're in a, roads were road roadways were constructed for people driving vehicles.
Mhm.
Something very interesting happened. Uh, Tesla released version 14.1.2 this week with a moding called Mad Max,
Yeah, yeah.
and people got it wrong. They thought it's the cars make it a perpetual speeder. Some people are like, oh my God, it's breaking the law type of thing. That wasn't the point of that release. The point was that, and by the way, it's a signal. It's a strong signal. If you believe that you can put out a version that is, uh, what am I going to try to say here? Uh, Highly dynamic and still safe. It sounds like you're very close to solving this thing called autonomy, right? In
Hmm.
other words,
Hmm.
so here's the thing that's interesting about this. Uh, people that people know this term that are into vehicles at racing and so forth. They know at limit driving, right? Which is sort of
Right.
like pushing the car to its very limits, and humans rarely do that well because they're not necessarily trained to do that. When I was at Rivian, I had the privilege of being enrolled in various driver courses and learning how to drive cars in ways that I was before that very uncomfortable with.
Right.
And things that I didn't think I could do with a car, and I was trained by a professional saying, "Yes, you can, and here's the limit." Um, so clearly, you can imagine robotically, meaning with the autonomous stack that Tesla's built, that car could drive a road at a much greater speed than a human is considered safe to drive a road. And if you just look a little bit into the future, just not into the future a bit, you can imagine, say with an AI5 chip where you're doing maybe 120 inference cycles a second. Now, what that means is that's the full compute of the car with its 8 cameras looking 360 degrees, 120 times per second around the vehicle. Now, if you think you as a human can do a better job determining if that vehicle to your left is going to come into your lane, or you understand the stopping distance between you and the vehicle in front of you, you're crazy. There's no way, no human that can perceive the environment and react faster than that. That's not possible.
Right.
So we're left with a situation where at some point, and I don't think very far into the future, I mean, like not even necessarily version 15, meaning still maybe on the version 14 stack.
Right.
We are at a place where the car is being held back in a fairly demonstrable way,
right,
because it shares the road with human drivers.
Right.
So it will be much safer than humans, and it is close to getting there. Remember the reason why what's happening here. Version 14 is a breakthrough version. Most people know it as the neural network version has 10x more parameters than version 13.
Right.
That's a characteristic, but it isn't a defining. It's definitional. What's more definitional about it is how it was trained. 13 was primarily trained on the form of what we would call imitation learning,
right,
which is what we do is we take driving samples from better than average humans, and we run them through a system to train this neural network, to build the model, to set the parameters. Version 14 uses that to create the base level model, and then leans in on this reinforcement learning, which is now setting up, to keep it very simple, setting up thousands of different trajectories and situational things that a human never really, there is no driving samples for these types of things, because some of them would be impossible some of them would involve deaths of individuals, right? Oh, I want to protect against hitting a pedestrian. Well, what samples do I have that would?
Yeah, right.
Yeah. So 14 not only changes the model. Sorry to reuse that term. The model at which they train the ultimate neural network model, which means that they're taking the imitation learning and but they're also leaning in on this concept of expert blocks.
Right.
And the two go hand in hand, because the reinforcement learning situations are almost not one for one, but tied to these expert blocks. So the idea that we can say when I say block, what I mean is a portion of the neural network, a portion of that neural network on the planning side, the part that determines what the car should do. That block may be organized to be the intersection expert, right? So it knows how to traverse through intersections. There may be another one that is good at highway driving or exit ramp, okay. And so these blocks that Tesla's building can become smaller and smaller and more specialized.
Right.
And then sort of can be chained together. So I'll give you an example. Something that happened in version 14 that people are pretty excited about is that version 14 can enter gated parking garages and go through drive-throughs at McDonald's and so forth. And oh my God, how does it do that? What level of sentience does it need to? So what's happening there is it recognizes the gate, it recognizes that it's a operable gate. It can't be a gate that's going to permanently structured to be down because that
Mhm.
would it can't get through it, right? It doesn't know what the human has to do to get through the gate. It doesn't know. It doesn't know whether the human has to pay, take a ticket, punch in a code, do some facial recognition. It doesn't know. But what it does is this expert block associated, they build an expert block associated with this behavior. And they say, okay, we're going to, as we approach, we recognize the gate, we approach the gate. The we swap into this mode of operation that says, wait for the gate to open.
Mhm.
Um, but also wait for the operator of the vehicle, in this case, it's supervised driving, to return to the supervised state,
Mhm.
right? So he's got his hands out the window. He's talking maybe to,
Right.
somebody at a drive-through. The gate and drive-through thing, I think, are identical, really.
Mhm.
Um, and he's doing these actions. And so what I say is that is a little expert block. And these expert blocks can be kind of swapped in, and they can be swapped in a preferential, like weighted way,
Mhm. Mhm.
um, meaning that the driving block is still sort of sitting there running, but the one that's taken control at 90% of is the one waiting for the gate to open,
Right.
right? And essentially, for those listening that get this, they're effectively able to pull these things together in the AI equivalent of a state machine.
Hmm.
So they can run through states, right? They can run through the wait at the gate state.
Mm.
Wait, yeah. And so this is what's happening in this stack at this level. And I think, we are so close to the idea of unsupervised operation. Remember, once Robotaxi drops the safety rider, observer, whatever they're called, then effectively it is unsupervised, right? I mean, at
Right.
that point.
Right. So it's
And
really unsupervised now.
yeah, well, sure, because what's going on in these, I mean, imagine, first off, if you've watched any videos of people running 14, it's quite amazing. Okay, it really is. It's like, people that don't see, there are people where I'll post something, I'll comment on something, and people say, well, we see autonomy is coming, yes. We see Tesla as the leader, yes. But we disagree about the timeline, and we think that, or I think that autonomy is reached somewhere between 2030 and 2040.
Yeah.
And I'm thinking, are you absolutely crazy? Like I'm taking a skeptical engineering point of view, and I'm telling anyone listening that we're pretty much at that door. We are at that door. What's part of the signal, the thing that I learned, I can read the tea leaves, is Tesla is starting to chase with version 14 the tail. It's starting to add features like the last, you know, gates and this drive-through thing and toll plazas and parking structures. If you're spending your time on that, it means that the stack is solid.
Yeah.
That's what it means.
Yeah.
Or
There was actually a commentary this morning that was talking about, this was just one of the early drivers. And he says, wow, he says, it's just absolutely amazing. He says, but my wife, who's not willing to even use it yet, she'll ride in the car with him, but she won't use it herself yet. She says, when it gets to unsupervised, she'll start using it. He says, so she's along for the ride. She goes, well, to me, it still has a little more jitters than 13, even after the two
Mhm.
updates. And so Elon just responded back. He says 14.2 will be the one that goes wide.
Yes, yes. And I wrote a post last week about the versioning and what I thought, and I literally posted this morning. I said, see, it is 14.2, because that's what I said last week. It will be 14.2. Yeah, so let's talk about the jitters or the brake
Yeah.
stabbing. There's another post I wrote about brake stabbing, which is what we're talking about here, roughly. So what's happened is, often when often when you have a brand new release like this, overall it can be a much safer release, but it's sort of like you built a much better human, but it's still an adolescent, and
Hmm.
it's going through the very first phases of getting tuned.
Hmm.
Right. So this is natural. Like it's nothing like I look at that and I go, it's not like a regression. They haven't gone, it feels like a regression. It feels like they've gone backwards. Like, oh, 13 was so smooth. But here's the thing. What was going on at 13? 13 was not operating as quickly from an inference and compute.
Right.
So it was smooth, but actually unsafe relative to 14. 14 is hyper safe. So these so-called jitters are sort of the lack of smoothing on the controls. Like think about what's happening here. If the inference stack at some inference cycle, like one cycle, looks at something and says, "Oh, I see that I need to apply the brakes because there's this vehicle." What's important is that the previous control values for the brake have to be fed back into that network to allow it to smooth it out, to
Hmm.
integrate the braking behavior over time.
Hmm.
Because you can't go from 0 to 1 on braking because you'll throw the
Sure.
passenger out of the car or have them, slam forward into the steering wheel or whatever. So you've got to get that smoothness. Now, if you take the entire brand new stack, which 14 is relative to 13, you know, retrained, started square zero, changed the internal architecture somewhat, um, and you just kind of get it to the perceivable finish line with a much higher degree of I just want to keep it out of the technical. Let's just call it higher degree of situational awareness,
Okay.
higher compute, greater nuance and compute within the inference cycles.
Sure.
You're gonna have these problems. And so how do you address these problems? Well, Tesla engineering gets to the task. So what they know internally is we've got a safer version. It's just not as smooth and comfortable. And people are confusing that. They've got that reversed in their brains. They're like, oh, smooth and comfortable means safe. No, it means that with 13, they tune the heck out of it to its perceivable, to its finish line, but it's nowhere close to the new adolescent in 14 that will grow up to be a good teenager in 14.2, and then we'll be at adult level
Right.
at 14.3 and so forth. Yeah.
Okay. So Jeff Lutz, Brian Wang, and I agree that in 2028, we won't have steering wheels in any US made cars, US made Tesla cars. So that gives us 2 years to get to the place where either all the cars are going into fleets, which is possible. I wouldn't be at all shocked if all 2028 vehicles are sold either to individuals like you and me for fleet purposes, are sold to actual fleets, or used in Tesla's fleets.
Mhm.
I think that's very likely that that is 100% of what they'll be sold for. That would be I would call that my base case. But even if there's still some being sold to individuals, those individuals are not going to be interested in driving those vehicles when they can use them autonomously. So there'll be no reason for them to have a steering wheel either. So that's why I'm saying 2028 in the US, because I think the regulations will be there. As far as the other countries and other continents, I think it'll be regulation driven. And of course, as the regulations change, then it might take a year or two
Mm.
the population to be
Yeah.
prepared
Yeah.
to be ready for them. So that's my sense.
Well, I think it's very, very light. I mean, I don't know if I agree with the timeline. And not because it's just because I don't know exactly how, the thing plays out. I would rather lean in and say it's darn clear to me that version 14 is um, effectively level 5 driving.
Right, right.
That will be the unsupervised capable version,
Mhm.
clearly, because it will be the stack that goes into robotaxi, and that by definition is unsupervised. The second they remove the safety, I mean, imagine tomorrow Tesla says, we have some version of software. They don't talk about that with respect to robotaxi, and we remove the safety drivers in Austin. I mean, imagine how people will be. Wait, hang on a second. I thought that it was still, 2 years out or 3 years out, or come on, that's not, imagine that happens.
Yeah, yeah,
I often think that you have to analyze scenarios, not just in the timelines, but you also imagine what if this were true. Like, imagine this comes true. And
right.
so, I think it's like, from a point of view of autonomy, it is quite clear to me that Tesla has achieved the goal.
Right.
And when I say achieved, I don't mean like instantaneously at this moment. It's like you see the path to convergence, and it's pretty clean and clear that it's soon. It's soon. It's not. I'm not like if people ask me, I'm like, no, it's not a version 15 problem. No, it's not an AI5 chip problem per se. There's things that chip is required for that go beyond just the straight up autonomous driving. So anyway, in terms of like, will they remove vehicle controls from all cars by that time? No idea. Are they capable? One thing is true is they're capable of removing the controls a lot easier than putting controls in a vehicle that never had them in the first place. It was designed not to have them. Cybercab argument. So I absolutely see that we will absolutely find ourselves. But again, the key thing here, which is, I mean, cool for us that are sort of selected into Tesla either as investors or interest, but odd in general is that unlike every other time there has been advances in automotive, even though those are like not big, jumps, the industry can't follow this or isn't choosing to follow this.
I know.
It's like,
okay. That's a great way to do a transition here. Disruption, and I think maybe Tony Seba was the first to see this. Disruption is almost always the result of technological convergences.
Yeah.
Okay. And then Cathie Wood came along and said, oh, that's exactly right. And she's based her entire last 20 years, I think, of her business on the idea of convergence.
Right.
All of these 7 or 8 different categories that she believes will be dramatically increasing in terms of value, but also our value of life over the next 5 years because of this convergence. Then Peter Diamandis came along and he goes, yeah, this is right. And it's going to end up being abundance. So we've had, and I think Elon has talked from time to time about these issues, but not as in such a focused way. So one of those disruptions, maybe the biggest disruption in history, is weeks or at the very most months away, which is Optimus. Optimus uses this exact same chip.
Yeah.
This is a convergence of the capability of producing a chip like that uses vision only, and the capability of making very small actuators and very good material science that would allow us to have a finished product that is smooth and can do sensitive tasks. That's my convergence. What's yours?
Yeah. Well, so last week I dropped an article in that series, A Magic of FSD, Part 8, and it's called the Optimus Edition. I was like, what? FSD, Optimus? Yeah, because what I'm saying there is that these architectures are unified architectures. At first glance you'd say, what does FSD have to do with Optimus? But they have a lot more in common by far than dissimilar in terms of their AI stack. And so Tesla is using what they've learned, both of them, both Optimus and the vehicle are vision-based AI systems from they're what I call action-based AI. In other words, they're taking in vision and their actuating controls to do what they do. We can set aside the reasoning component for another discussion per se, because that is something that both of them will get. Both of them will get. But so they, from an architectural point of view, in that article go through, I think, 5 or 6 different things that explain how Tesla is unifying the architecture, bringing it together from data formats to data pipelines, the big infrastructure that moves the data around off of vehicles, and the training system and how they do both imitation and reinforcement learning, ultimately down to the inference architecture on vehicle or inside Optimus, driven by the proprietary AI chip, right, which is currently AI4 or hardware 4, from a changing nomenclature, and then as they deliver AI5 chip in 26. So what Tesla's done, and they've signaled this, they've put the entire autonomy program under VP Shock. I don't remember his last name, but
anyway, yes.
Yeah, he led the FSD effort, and now he leads both for AI, and he now leads that for Optimus as well. They've consolidated, and these systems are converging very quickly. Now, I believe that it's interesting, Randy. If you let's pull out a Tesla and give the viewers perhaps a different kind of way to think about this. So at Apple, and when I was at Apple, the watch team that developed Apple Watch, it's an iOS based variant, and when they started that project, they forked the build. What I mean by that is, here's iOS that principally runs iPhone and iPad, and so they decided, well, it would make sense to run this on the watch. Actually, the VP who came in from Adobe, Kevin Lynch, made that decision, which was a controversial decision, because the team that was there before them thought that they would use the old iPod. Let me say that right. iPod, yeah, the music player operating system, which was much tinier, and they felt Watch's small system. But what they did was they forked the build. Now, why am I saying this? Is this gave the Watch team, velocity, autonomy, their own control over the outcome here. But at the same time, it's a trade-off. It creates a problem. And the problem generally is that if they fork this build and they start modifying the kernel or aspects of the lower level components of this thing, now they start to find themselves peeling apart. And this creates a problem for the long term. Short term, it's valued. If I was an engineering manager in that org, I'd say, let's go on our own island. And then Apple kind of regrouped this with what they call core services, where they took many of the core elements of that thing and they brought it back into a more central core set of core services that get built for both products. So there isn't like now a separate build for Watch on that level. Anyway, this is sort of, I think, the same thing that's happening at Tesla. Optimus is a product that came in later stage than FSD. FSD was a project underway. Optimus was clearly going to use an extreme amount of AI. People that are smart could see the similarities. The team probably didn't see it as the team that was given control of Optimus in the early days, engineering-wise, wanted to test and trial their own methodology, but then as FSD matured and became you remember, Optimus started pretty much when FSD still hadn't switched over to a full end-to-end AI
Right.
systems. So if you were running the Optimus team at the time, you could look skeptically at the FSD team, right?
Hmm.
You could look at that team and you could say, well, I'm not sure they're going to make this happen, right? So I'm not in charge of that. I'm in charge of this thing called Optimus. And so I've got to move that forward. And I think they started to move it forward in fits and starts. And then this thing FSD got bigger and bigger and bigger. The team got the teams got mature. They developed mature processes, the data pipelines I'm talking about, data formatting, and then any sensible uh, engineering manager would say, how do we reuse the components and build one stack since they're both action-oriented vision systems. The difference is the actuation of the controls, right? Obviously, the actuation of the controls in Optimus are much deeper than the car controls. Cars are easy. Optimus is complex, but the input sensors are the same. The AI, the perception and planning stacks can be the same, and I claim in this little article I wrote that they are the same.
Hmm.
And that is where they've. So this is great if you're a Tesla investor or a fan. You get this. In this case, I think this is a unique time where you see Tesla having its cake and eat it too. Like instead of having Optimus as a team that's split off from this other AI, it's now pulling it in directly.
Hmm.
And so remember, if you go back to the beginning of my little story here, I said I was talking about iOS and Watch.
Right.
iOS was mature at the time it was forked off for Watch, um, and I think when Optimus started, FSD was not mature.
Hmm.
So now FSD, has developed all these elements of the stack of the tech stack, the AI portion of this that and then when the resulting uh, inference side, like when we get all the way through everything that happens in the data center and training and all that, and you get right down to the device, the compute side of that device, which we now refer to inference because that's what we refer to as AI compute. Um, they're the same architectures, right? They're or will be certainly the same architectures. So it's a grand convergence here, and I think what's cool about this is that if done right, I think the advantage that Optimus has over Apple is that that these products at Tesla have over Apple is that there's a lot less bureaucracy
Yeah.
at
Yeah.
Tesla. Yeah, there's a lot more direct top control.
Well, there's I don't know. There's some guy at the top
There's
who
this guy at the
I
top.
don't know. He has ideas from time to time.
Yeah. Yeah,
Sometimes
I mean, no, but
sometimes they're
it's
the smartest in the world.
yeah, I mean, it's really, really important to recognize that when you have a tech review and Elon goes into that tech review and you have a guy that actually runs the company, has the technical capabilities to make decisions, those decisions can be made fast. And frankly, if you're on those teams, you're usually very happy to see those decisions made.
Oh, yeah. Yeah.
Yeah, because it literally cuts out the bureaucracy, it cuts out the political infighting, it clears the path, and I think if any company can converge two perceivably different architectures, even though I claim they really aren't, or they were, they aren't, and they won't be. um, if any company can do it, Tesla can do it because of how it's how it's controlled at the top. So yeah, I mean, this is what we've got coming. And what's really cool about this, I think, is that uh, Optimus is sort of learning from the FSD, but that's feeding back the other way too.
Sure. 100%. Yeah.
It's feeding back the other way too. There's stuff that they've learned in Optimus that will allow them to apply. And I'll give you one example that is a little bit off of the obvious path. Is unlike the car, today, really, from an FSD perspective, today, what we do with a car is we say, I want to go here. You put it in the routing. You go into the maps and you say, I want to go here. And then you engage.
Right.
And that is literally the last time that you, other than disengaging or changing your map destination, your routing destination, that is, you have very little interactivity with the FSD stack,
Right.
right? The only, it's keeping an eye on you. You're supposed to supervise, so it's saying, are you there? And when you're not, it complains and annoyingly, and that's it. That's it, right? Now, Optimus, on the other hand, is clearly, just very obviously not something that is going to have low interactivity. It's going to have very high interactivity. So I claim that there's a whole new portion of the stack. I talk about it in the paper, in the inference section, that there is this whole portion of the AI stack called the reasoning and interactivity stack, and that will be brought to you through the tech stack that xAI is building. Right. So xAI will contribute essentially AI that will do speech to text, a human talking to Optimus. It will deliver the LLM or the reasoning component, and it will deliver the text to speech, the Optimus talking back to us.
Right.
That same stack will essentially be moved into the car. And so the car will talk to us and reason with us, and those are great advantages. For the first time, we'll be able to talk to FSD. In other words, you've got two. I don't have my slides in front of us here, but we've got the Action OS. Action AI, and we've got the Interactivity Reasoning AI, and they need to talk. They need to talk, and so most these inputs going upstream from reasoning to action will allow the car to do things like, like you could actually say, please wait for the gate to open, or even if you think that has to be automatic, or please take this lane through this gate structure.
What you're saying is that poor Grok is going to have to deal with backseat drivers.
Yeah, absolutely. Well, FSD, yeah, right. I mean, yeah, absolutely. But I mean, it becomes what it means is that it becomes a very fluid process where you don't, because right now it's kind of, right now you interact principally through, you set the map and then you engage, right? And it seems like it's simple, and it is pretty simple, but wouldn't it be easier if you got in the car and said, take me to the Presidio, and take me to San Francisco Airport, and then if you didn't get it right, the stack would say to you, well, what terminal are you going to? Oh, I'm going to Terminal 3. Do you want arrivals or departures? What deck do you want to be dropped off at? Or what are you doing? And then you can kind of modify the route. You can ask questions about traffic, and then you could just ask the thing other questions like, what's some weather going to be like? I'm going up to Napa. Is it raining in Napa today? So these things are, I think the reasoning action side is driven primarily by Optimus, high agency requirements. Like it's part of that product, right? But that stuff will come down into the vehicle clearly. And as we said prior episodes, and I've said 250 times, this Grok is effectively the interface for robotaxi.
Yeah, exactly. Yes. All right. Well, we covered exactly what we promised to cover. I mean, how did that happen? And I do want to mention to people that today is a huge news day. I touched on just one news item. Normally Saturday is kind of a light news day, but I mean, it's probably going to be an hour show just for the news. No, maybe not. But anyway, that's coming up today, probably around 4:30. And then later this afternoon, wait a minute, that would have, wait a minute, I'm forgetting where I am. It's 7 o'clock. You're watching this after 7 because this will be the
Okay.
late show tonight. If you didn't
Okay.
watch the news show,
Go back.
go back. I'll put the card right here to go back and watch the news show, and then a regular slate of shows on Sunday. Anyway, yeah, I got to remember when in the future I'm
Well,
learning.
you have a problem I don't have. I show up at 9 a.m. to do this with you. You determine whether it's slotted in all the other shows.
So,
I just sit and listen, and go, okay, you work out the schedule for your viewers.
right. Well, Phil, as always, you've enlightened us in ways that nobody else could have, and that we need to be enlightened if we really want to understand this entire process. Phil also is a contributor to the book, AI
Yeah.
Rising, and the book might be done right now. I'm waiting to hear from my formatter, Sarah, who's been with me for 10 years and done 10, she and I have done 10 books together in 10 years. That's pretty cool. And so maybe later today it'll be done, and maybe by Monday or Tuesday it will be up and ready for people to place their pre-orders. So
Awesome. Awesome.
so Phil, really excited to have you along on that journey as well.
Yeah, it's awesome.
All right, okay. So
Okay.
that's all. That's it. It's been fun and great and amazing talking to you.
All right. Thank you.